Geometry. This is section 4.4. I'm going to do a little bit of a review from section 4.3. It was also proving triangles congruent, but it was using the side-side-side method and the side angle side method. So we're trying to prove that two triangles are congruent, like these two here, okay? And I can say that those two triangles are exactly the same, or they're congruent, if I can say that all three sides of one triangle match up with all three sides of the other triangle, okay? If I can do that, I don't even have to talk about the angle measures of each one. Those angle measures have to be the same because all the sides are the same, okay? Or if I'm able to say that this side, this angle, and this side are the same as this side, this angle, and this. Oops, I only meant to do two there. So this side, this angle, this side, and this side, this angle, and this side match up. If I'm able to say that, then I don't even have to talk about this bottom side. I don't even have to talk about these two angles here and these two angles here. Those angles and that bottom side have to then be the same because of the side angle side theorem, okay? Now, this section is angle side angle and angle angle side. So in the first angle side angle, which is postulate 4.3, which we're going to write down on our green sheet, so make sure you have that out. If I'm able to show that this angle, the side in between, and this other angle are the same as this angle, this side in between, and this angle, then those two triangles have to be congruent. They have to be exactly the same. I don't even have to talk about this angle or this one, or this side and this one. I don't have to talk about them because it has to. Those have to match up then to this one. Has to be. Okay. So that's angle, side angle, and we're going to add that to our green sheet here. So grab that quick. And, oh boy, again, kind of down to the bottom here. All right, so let's go back and we'll use a different color again. This is postulate 4.3. So POST 4.3. And this is angle, side, angle. Angle, side, angle, congruence. ASA is how you abbreviate it, okay? So if, I'm just going to say, if angle, side, angle of two triangles are equal, then they are congruent. Okay. All right. If you need to pause this, go ahead and do so. I'll draw a picture of what this looks like. All right. And the thing to keep in mind, angle side angle. Angle side angle. Angle side angle. We'll do that. Okay. Don't ignore this little tick mark over there. So angle side angle. And angle side angle, just like that, okay? Now the thing to keep in mind is that the side that you have has to be the one right in between the two angles. Kind of like the angle here for side angle side had to be the angle in between the two sides. For angle side angle, the side has to be the side that's in between the two angles, okay? All right, so there was the angle side angle congruence, and we're going to do a proof with that. So back over here to the angle side angle triangle congruence, okay? They give you a hint that we are using this method, angle side angle, to prove these. So pretty much what we do is we look at our given, we write down our given, and then we figure out what else we need to prove that the triangles are congruent. So it says QS bisects PQR. I'm going to write that down for the given. QS bisects angle PQR. So let's look at what that means. QS is this side right here, and it's bisecting the angle PQR. So this is like splitting this angle right here, this angle, into two pieces, right? So in other words, I can say that this angle right here, this top one, and this bottom one are exactly the same. Well, let's do that. That's what that means to bisect. Okay, this is my given. That means that angle PQS, this top one, PQS, and RQS are congruent. Angle RQS, those are the same. And that given That is the definition of angle bisector. That's what it means to bisect an angle, is to split it into two equal angles, okay? So now I can say that those things are equal, all right? We've got that going on now. And then we have PSQ, angle PSQ, this angle right here, and RSQ, this angle here, those two things are the same. So we've got another angle. So give us that PSQ is congruent to angle RSQ, and that's another given. Okay, again, you don't always have to write your givens right at the very beginning. You can kind of write them as you use them. Okay, and that's all I have given. Crap. Whew. So if I look at this top triangle here, I'm trying to show that that's congruent to the bottom triangle, right? And what I have is an angle here and an angle here. I've got two angles. So if I look at my angle, side angle, I've got this angle and I've got this angle, okay? And what I need is a side, and that side has to be the side that's in between the two angles. So if this is an angle and this is an angle, the side in between them is this one. Well, isn't this side for the top triangle congruent to the same side for the bottom triangle, right? SQ is congruent to SQ. SQ is congruent to SQ, and remember what that was? That is the reflexive property, okay? It kind of seems silly that we would write that SQ is congruent to SQ, but we're saying the SQ side for this top triangle and the SQ side for this bottom triangle, okay? So now I have my angle, side, angle. Again, the side is in between the two angles. Angle, side, angle for both the top triangle and the bottom triangle. And when those are the same, then I can say that triangle PQS is congruent to triangle RQS. And that is for the angle, side, angle congruence. Okay, and that's it. Done. All right. Now the last one that we have is angle, side congruence. Okay, so again, I can show that these two triangles are exactly the same. They are congruent. They're the same shape and same size if the angle, side from this triangle is the same as the angle, side from this triangle. Okay, so that's how that one works. Let's write that down on our sheet here. Angle, side. Angle, side congruence. Getting worse at writing this. Angle, side. And that was postulate 4, I think. Yep, no. Oh, wait, what? 4, 5. No. Theorem. Gosh dang it. Theorem 4, 5. I don't know why this one's a theorem and the other one's a postulate. I don't know. It must be more exciting. What's the matter? What's the matter? Right. Okay. Hold on just a second, guys. Okay. Now let's write an explanation. So I've got angle, side. If the angle, side of two triangles are equal, then they are congruent. Okay? And I'll write out what angle, side is. Here's my triangle, here's my other one. So this angle, and this side. This angle, and this side. Okay? Now, you might be asking, well, what happens if it's the other side? Can it be the other side? That would still be angle, side. So I can, if I do this angle, on this bottom side, and this angle, on that bottom side, that's still angle, side. So it doesn't necessarily have to be, it could be either one of those sides. It's not restricted like this one and this one are, where it has to be the angle in the middle. It has to be the side in the middle. Okay, this could be angle, side this way, or angle, side this way. Okay, both are the same, right? Okay. So going back, they're going to have us do a proof with this in the back side. So angle, side. All right, so we're going to use what we're given. And these diagrams, I hate when they have like two triangles going on at the same time. So this one here, if we look at this guy, I'm going to rewrite him over here. Let's see if I can do this. There we go. CAD. rewrite what he looks like. Okay, then I'm going to do this one. I'm just going to separate them so it's easier for me to see. Okay, so this bottom one, oh lordy. Let's do this. So this is C, E, B. Okay, if you want to go ahead and do the same thing, you sure can. We're trying to prove that those two triangles are congruent. Okay, so if you kind of look at the way that this is, those two triangles should end up being the same shape and same size. They don't quite look like it, but if you take this pink one and you reflect it and like flip it down and rotate it a little bit, it will end up being with the same shape and same size of that blue one is. Okay, so we've got to prove that. We've got to prove that these two triangles are exactly the same shape and same size. So I'm going to do all my markings over here on the pink and blue triangles. So we've got that DAC. DAC is this guy right here. Okay, and that's congruent to BEC. BEC, that's this guy right here. So now we've got an angle. Great. We've got one of our angles I'm going to cross off. Okay. All right, and then they give us a side that DC is this bottom side here. That's the same as BC. That's that side there. Okay, so I've got those two things. Here's what I'm going to do. I'm going to cheat. Given. Instead of, I'm being lazy here. All right, so given. All right, so I've got an angle and I've got a side. We've got to find another angle that's the same. Another angle that's the same. Well, I either need to say, I only have two other angles that I can use. I can either use and say that D is the same as B, or that C is the same as C. Well, isn't this angle C the same as this angle C, right? They're the same angle. So that's the one that I'm going to use. I'm going to say that this angle C is congruent to this angle C. Angle C is congruent to angle C. Again, that's that reflexive property, which kind of seems silly to write. But again, we're talking about angle C in this triangle being the same as angle C for this triangle. They just happen to both be the same angle C. Okay, that's a reflexive property. Well, that gives us angle, angle, side. Angle, angle, side. So I can say triangle ACD is congruent to triangle ECB, and that's angle, angle, side property. Done. That was a really nice proof. I kind of like that one. It's hard to see when you have those two triangles together like that. So if it helps you, separate them into the two pieces, and that really makes it easier. Okay. All right. Okay. Example 4. Apply triangle congruence. So Jeremiah is working. Let's see if you can see this. Jeremiah is working with a community service group to build a bridge across a creek at a local park. The bridge will span the creek between points C and B. Okay, I can't really see how this is working here, so I'm going to do this. I'm going to draw this picture over again. And we've got a thing connected in between right there. This is B, C, A, D, and E. And then I've got, this is a right angle and this is a right angle. Perfect. Okay. All right, so the bridge will span the creeks between C and B. This is where I want my bridge to be. All right. Jeremiah located a fixed point D to use as a reference point. So here's his reference point. So that the segments have the relationship shown. A is the midpoint of CD. Okay. A is exactly in the middle from C to D. So what that tells me is that this segment here is the same length as this segment here. This length is the same as this length if the A is exactly in the middle. That was the midpoint theorem. We're not having to write a proof down, but that's what my justification, what my reason would be for me saying that those two are the same. That's the midpoint theorem. So I know that this is the same as that, right? A is the midpoint of CD, and then it says DE is 15. DE is 15 feet. 15 feet. How long does the bridge need to be? Well, it would seem as though if this is 15, this would also need to be 15, right? So we should just say 15, okay? But we can only say that if those two triangles are exactly the same, okay? So we have to prove that those two triangles are congruent, all right? So I know that this side is the same as this side, and I really know that angle D is the same as angle C because both of those are right angles, right? So what I need is probably, if we're going to do angle, angle, side, angle, angle, side, I need another angle, right? I have an angle and I have a side. I need another angle to say that those two triangles are the same. So let's talk about this angle here and this angle here, E and B, Okay, is there a way that we can say that E and B are the same size, or the same size of an angle? Okay, well here's a way that we can say this. Since we have this perpendicular, since it's perpendicular, since this AC or DC running through here is perpendicular to this line and is perpendicular to this line, these two lines, this top and bottom line, have to be parallel to each other, right? If this one's perpendicular to this line and this line is perpendicular to this line, then the top and bottom ones have to be parallel, right? Okay. Well, then this guy right here running through here is a transversal, and this angle and this angle are alternate interior angles. Okay, and alternate interior angles are the same. So this angle is the same as that one. This angle is the same as that one, and this side is the same as that one. So we have concluded that these two triangles are the same by angle, angle, side, and then we're allowed to say that, hey, since this guy is 15, this one has to be 15 also, okay? So by guessing, we knew that that was 15, but this proves it. By angle, angle, side, we have drawn another triangle, and those two have to be 15, okay? All right. This box down here is a good place to come back to, so put kind of like a star by here, because this is where you're going to want to go to study when we finish chapter 4 and you go to start studying for a test, because it has the side, 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 angle, side, angle, side, angle, 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 side. Those are the 4 methods of proving that triangles are congruent. This is just the concept summary for that. Now, one thing that I want to talk about before we're done, because this is the end of the notes, is that there is another way to arrange the A's and S's, and it is this. And you're like, oh my gosh, Mrs. Comacher is drawing a naughty word up on the notes. ASS is not a way of proving that triangles are congruent. This would be like angle, side, side, okay? And let me give you a demonstration of why this doesn't work, okay? If I have two triangles that have an angle, a side, and a side that are the same, they don't necessarily have to be congruent, okay? Here's an example of that. So let's see if I can draw this nicely. Yeah, here's what I want to do. Okay, so here's my triangle, okay? And let's say that this angle is 20 degrees, and this side right here, and this side right here. So here's my angle, side, side that I'm looking at, okay? And I'm going to draw another triangle right on top of this guy that has that same relationship, that angle, side, side. So here's my other triangle. This triangle, this side, and instead of this side being over here, I'm going to swing that side over here to make it the same length. So now I have this angle still, this side here still, and this side here now. That's the same as this side. So rather than it being this blue triangle, I'm looking at this pink one here. They have the angle, the side, and the side being the same relationship. You know, they match up, but those two triangles are not congruent, obviously. The blue one is not the same as the pink one, okay? So angle, side, side is not a way of showing that triangles are congruent. Only these 4, side, 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 angle, side, angle, and angle, angle, side. If those 3 elements on each one match up, those triangles have to be exactly the same. They have to be congruent. Not the same with angle, side, side. So ASS does not work. All right? And there you go.